Hello everyone, welcome to Hargharshiksha. So today the topic that I have taken is sets, that is for class 10, first chapter, and little boring, but I will try to make it interesting. Okay, so let's start. So the topic is sets. So what do you mean by set? Set may be defined as a combination of different elements. Okay, like a set of natural numbers. If I tell you, then a set of natural numbers can be represented as n is equal to, let us start, 1, 2, 3, 4, and so on. Okay, so this is the set of natural numbers. Now let us take the set of integers. It is denoted by z. Okay, now how it will start? It will start from minus infinity, so on, 0, and then plus 1, all positive digits, and then it will move to infinity. So this is the set of integers. Okay, and if it is denoted by plus, then it is for positive. If it is denoted by minus, then it is negative, and if it is not denoting anything here, plus or minus, then it is for all, negative, positive, as well as 0. Okay, so now we can take set as q, which is the set of rational numbers. Okay, whenever in the question you are being given q, z, n, then it stands for the right hand side, whatever I am writing. Okay, so there should not be any confusion for that. So this is the set of rational numbers. Okay, you can write here also set of rational numbers. Okay, rational numbers. So this is denoted by q. Then what is left? Then r is left. What is r here? R is the set of real numbers. Okay, set of real numbers. You can represent it in this way. Then what is c? C is the set of complex numbers. Okay, set of complex numbers. So this you have to keep in mind. N is for natural numbers, then Z is for all integers, the positive or negative, Q is for rational numbers, R is for real numbers, and C is for complex numbers. Okay, this much you have to remember. Okay, now let's move further. Sets can be categorized in two ways. Okay, one is in roster form or tabular form, R-O-S-T-E-R, roster or tabular. Okay, tabular form. And the other thing is set builder. Set builder. It can be represented as roster form or set builder form. Now, what is roster form? If I am writing like, say, set of vowels in English alphabet, A, E, I, O, U, then this is roster form. Okay. And what is set builder? If I am writing X such that X is vowel of English alphabet. Okay, English alphabet, then this is called set builder form. Okay, one is roster, or you can say tabular form, and the other is set builder form. Other examples also I will be giving you. This is set builder form. Okay, now let us move further. Like if you are told to write mathematics, you have to practice it. Okay, if you are told to write mathematics in both forms, mathematics, now you are told to write it in roster form, then how will write it in roster form? It will be like all the alphabets you have to write and don't repeat it. Okay, like M, if used once, will not be repeated twice. M, A, T, H, E, again M is there, it has already been used, so it will not be used now. A will not be used now, T will also not be used, I will be used, C will be used, S will be used. This is what? This is roster form. Okay, this is roster form. Now in set builder form, how will write? If you are told to write this in set builder form, can you write it? So okay, think of it. See, logically, if you see it, this kind of question will not come in your exam to write it in set builder form. But if you are told, or if you are compelled to write it, then how will write? I can write here like X such that X is an element of M A T H E M A T I C S. Okay. Now this is just, you can attempt it in this way, okay, but it is not so simple. If in the exam you are compelled to write it, then you have to write in such a way, okay, but you will not be told like this, okay. Now I will be increasing the level little bit, okay. Now here I will write roster form just to make you understand. Here it is set builder form, okay. Now here if you are given a set, say 1 by 2, then 2 by 3, 3 by 4, 4 by 5, and so on till 9 by 10, okay. Now you have to write it in set builder form, okay. So here you have to analyze. Now here if you analyze it nicely, then you will get it as x such that x is equal to n by n plus 1 with n element of natural number and n less than or equal to 9, okay. These both are same, only the left side is roster form and the right side is in set builder form, okay. Now I will give you some other example also. Here if you are given one set as 1 by 4, 1 by 9, then 1 by 16, then 1 by 25, and never ending, so on, okay. How you will write it? It will be 1 by n square, okay, with n element of n, means all natural numbers, because it is never ending, it is going till infinity, okay. So this and this, left hand side and right hand side, both are same. So in this way you have to practice. There are many questions, so I will not do all that, but you have to practice in this way, okay. Let us move further. Now if you are told about empty set, what is an empty set? Empty set means which is empty. Empty means vacant, है ना? So if a set is in this way, there is nothing here, this is called empty set, okay. Then there is singleton set. Singleton set is what? Which consists of single element, like there is 1, or it may be only 2, or it may be 3. Only one element is there in the set, okay. So this is called singleton set, okay. Now I will tell you about finite set. Finite set is which has finite number of elements, okay. Finite set. If there is a set like 1, 2 and so on till 10, okay, so this is the finite set. If I am taking 1, 2 like this and then infinity, okay, then this is an infinite set, because if you are told how many elements are there in this set, you don't know it, okay. So this is called infinite set, okay. Then equivalent set. What is equivalent? Don't confuse between equivalent and equal. This I am talking about equivalent set, okay. Equivalent means if there is a set, say A is equal to 1, 2, 3, and there is a set B with element 4, 5, 6, then these are equivalent. Why? Because number of elements in A is 3 and number of elements in B is also 3. So the number of elements decides the set is equivalent or not, okay. So these two are equivalent sets. Now there is one equal set. Equal sets mean all the elements in the set A will be equal to the elements in set B. Like if A is equal to 1, 2, then B will also be having 1, 2 or 2, 1. So these are called equal sets. All the elements in A should be in B and all the elements in B should be in A, okay. So these are some terms you have to remember or understand, okay. Let us move further. Now what is a subset, okay. We were talking about set, now this is subset. Sub means smaller than set, okay. So if there is a set, say A is equal to 1, 2, 3, 4, okay, and if there's a set with B as 1 and 4, okay, we will write B is a subset of A, okay, because all the elements in B are also there in A. Okay, but A is not a subset of B. Okay, very simple. Now, if this you have to understand, and I'm going further. Okay, if there is a interval like this, A B, means this set also contains A as well as B. Okay, if there is a set, say 1, 2, 3, 4. Okay, then what are the elements here? 1, 2, 3, and 4. But if there is a set, say in this way, the first bracket is in this way. Okay, and you are told that let us take some set like say here it is -1. Okay, and then here it is 2, and then there is closed interval. Then what are the elements in this is equal to? Okay, now here you can write -1 will not be there. Okay, because here it is open, and then you can write 0, 1, and 2. These are the main elements of this set. Okay, if I am excluding 2 also, if here also it is in this way, then what you will write? 0, 1, 2 will not be there, -1 will not be there, and 2 will not be there. If I am writing as -1, 2, here it is open, here it is closed, then -1 will also be included. -1, 0, 1. These three elements will be there in this set. Okay, so this is a closed interval. This is a semi-closed or semi-open interval. Okay, this is open interval. Open interval. So whenever you are talking about intervals, then you have to understand what does it mean. Okay, this is also semi-open or semi-closed interval. Okay, so I think this is clear to you. Now we will move further. Now what is universal set? Universal set. Universal means bigger, isn't it? So if you are taking a subset A is equal to 1, 2, 3, let us say B is equal to, let us say 7, 8, 9. Then what is universal set? Universal set will contain all the elements of which we are talking about, like 1, 2, 3, 7, 8, 9. This is called universal set. Okay, universal set. So you have to remember this also. Now power set. Power set is the set of all subsets of a set. Like I will write it below. 1 second. Like there is a set A is equal to 1, 2, 3. Then what are the subsets? Means power set of A will be equal to, how will represent it? First of all, a big bracket is here, then all the subsets. Like I will write here 1, then I will write here 1, 2, then I will write 1, 3, then I will write 1, 3 is there now. 1, 2, 2, 3, 1, 3. Okay, so and 5 also you can write. 5 is also a subset of this. Okay, then 1, 2, 3, all this is also a subset of this, isn't it? In this way. Okay, so this is called the power set, means all the subsets of the set. Okay, this will be called as power set. The number of the subsets that is contained is 2 to the power n. Here 3 elements are there, 2 to the power 3 means 8 should be there, isn't it? So how 8 we can get? Like what will be the other elements? Let me take. Let us ignore this bracket. Now what other elements can come? 1 is there, 2 can also come here. Let us take 2. 3 can also come here. Let us take 3. 1, 5 can also come here. 5 we have taken. 1, 2, 3, 4, 5, 6, 7. Okay, one more is left. Then have we taken 2, 3? No. 1. This subset also we can take, that is 2, 3. Okay. So now it is having total of 8 elements, isn't it? To the power 3 to 8. So if you are told to write the subsets of this set, then you have to first check how many elements are there. Then we have to take it as exponent, and then we have to find out what the value comes after doing 2 to the power n is equal to the power 3 is equal to 8 like this. Then you have to check that the number of subsets that are taken is equal to this number or not. So total number here is 1, 2, 3, 4, 5, 6, 7, 8, and here also it is 8. So all the subsets means you have to check that it is taken or not, and no subset should repeat. Okay, like if you have taken one once, then again you don't have to repeat only one. Okay, So let us move to some other topic. Now we will talk about Venn diagrams. Okay, what are Venn diagrams? So first we have to make a box. This is called universal set, you can say. Then there is a set, say A. Then there is a set, say B. If there is nothing in common in between them, then this is called disjoint sets. Okay, means there is no common in between them. If there is a universal set, say U here, let us write here U. Okay, this for whole. If we are taking A here like this, B is like this is A, this is B, this is common between them. Okay. Now, if we are taking this one, the shaded portion, this is called A intersection B, means common between them. Okay, whatever the common elements are there, it is A intersection B. Okay, and if we are taking this whole, say one more I am making here. Say here there are two sets. This is A, this is B. If I am taking this whole, then what is this? This whole is A union B. Okay, this is called A union B. And now if I am taking here as only one set A, and except this circle, whatever portion is left, that is called a complement. Okay, so you have to understand this. If there are Venn diagrams, you will be asked questions in this way also. Okay, disjoint sets, you have, they can say, you've seen this is intersection of sets. Okay, common intersection, whatever you can write here, these are called disjoint sets. It can also be there in the diagram like this. One set is here, one set is here. This is A, this is B. Obviously A is a subset of B. Okay, then let us move further. Now if there is a universal set in this way and two sets I am writing like this. Okay, now if you are told to write A minus B, this is A, this is B, what will be A minus B? Then this whole is A. If you are subtracting B from it, then this portion will be left, isn't it? So this is A minus B. In the same way, A plus B you can write, B minus A you can write. Okay, A complement you have already seen, so this much is enough. Let's move to next topic. Okay, now we will talk about laws. Okay, laws of algebra of sets. Laws of algebra of sets, or you can say theorem. Laws, or you can say theorem. Okay, now first, this is called idempotent laws. Okay, idempotent laws. What are they? A union A is equal to A. Okay, A intersection A is equal to A. Now if you apply the logic, let us say A is, the elements in A is 1 and 2. Then if there is a set A with elements 1 and 2, okay, and then again you are taking the same set and you are trying to find out the union of that, then it will be 1 and 2 only. If you are taking common, then common is 1 and 2 only. So logically also you can think that this is correct. So you have to remember A union A is equal to A intersection A is equal to A, means if the common between the same sets is taken or the union of same sets is taken, the answer will be the same set only. This is called idempotent law. Okay, now we will take identity law. Identity law, it means A union phi, which is a null set, will be equal to A only because this is a null set. Okay, and A intersection universal set is equal to A only because A is only common between universal set. This is called whole universal, this is whole universal set, and this is A. So the common is only this one. So you are taking as here A. Okay, so this is called identity law. This is called idempotent law. Okay, now let us move further. Then we will talk about commutative law. Okay, commutative law you have learned for before also, but this is for sets. That was for other things, isn't it? This is commutative law is everywhere. Now let us see this is true for sets or not. Commutative law, you can write it as A union B is equal to B union A. Okay. And the same thing is applicable for intersection also. That is A intersection B is equal to B intersection A. And you can write example also for that and analyze it. Okay. Now let us move further. I will talk about now associative law. This is called associative law. What is it? A union B union C is equal to A union B union C. In the same way for intersection also, A intersection B intersection C is equal to A intersection B bracket close intersection C. This is called associative law. This is also to be remembered. Now we will talk about distributive law. Okay. Distributive law. Okay, what is it? A union B intersection C is equal to A union B intersection of A union C. Okay, in this way. And then if you are taking intersection here and union here, then this will replace by intersection, this will replace by union. And same thing. Okay, so this is also clear. Now we will talk about De Morgan's law, most important. Okay, so please remember it because this comes mostly in exams also. De Morgan's laws. What is it? A union B complement is equal to A complement intersection B complement. Okay, or you can also take one more. A intersection B complement is equal to A complement union B complement. Okay, this is called De Morgan's law. So you have to remember all this, practice, and what you have to do is take some sets, like take A as 1, 2, 3, take B as 3, 4, 5, then take its complement, then see this side also. If this side and this side are equal, there are many questions which will tell you to prove this, that both are equal. So if you take the example, or if in the question there is a set given, you can take that also and you will get the same result. Okay. So this is also clear. Now what topic is left? Okay, almost all the topics I have covered. Then now you have to do practice, practice, and practice. All the questions you have to practice. And whatever doubts you are having, you can comment also. You can contact me also. You can take help of internet also. But if you are having a doubt, you can always comment. Okay. And at last, like, subscribe, and share. Thank you very much. Take care. I will be updating the second chapter also within 2-3 days. Bye bye. Take care.